Welcome, everybody, and good morning, good afternoon, good whatever applies in your time zone. This session is about budgeting with Power BI. Now, before we go on with the session, a few slides about PASS. You are looking at the session right now at the Virtual PASS Summit, the first because of the pandemic. Explore everything that PASS has to offer you. You have training opportunities. You can engage with local PASS chapters. You can do a lot of interesting activities with PASS, which is all about connect, learn, and share information together. And another extremely important topic is session evaluation. Spend some minutes to evaluate the sessions. Evaluations are super important for both speakers and the pass because they need to understand whether everything went fine, but also for speakers. I really enjoy reading the evaluations and don't think that they get unnoticed. I read all of them because evaluation are the only way we can actually learn how to improve and how to provide better content to you in the future. With that said, a couple of words of presentation. I'm Alberto Ferrari. I work with Marco Russo at SQL BI. We have a website, sqlbi.com. I'm a trainer, I'm a consultant, I'm a speaker at events, both virtual and in person, and I wrote books, I do videos, I do a lot of stuff, which is all related to analysis services, tabular, Power BI, and most important, the DAX language. Now, this session is about budgeting. So we are going to talk to see a scenario where budgeting is of paramount importance. And the good thing, well, the good and the bad thing at the same time about this session is that the slide that you are looking at now is the only slide we have available. The scenario is that we have to do budgeting. So we want to build the budget. We are simulating being at the end of 2009 because we don't have data later than that in Contoso. We want to build the budget and we love Power BI, we love DAX. We want to explore what we can do with just a set of budget data and Power BI. With that said, I'm gonna now close the slides and we jump straight to the demo. Now, the fact that we are going straight to the demo has some relevance for you too, because you will need to pay attention. You will need to follow the full session because there will not be a point during the session where you can recover. You need to follow from the beginning to the end. Otherwise, it's very easy to get lost, and I really don't want to lose you. Last detail about questions. There is some kind of delay between when I speak and when you hear what I say. So live questions are kind of hard. If you have any question, just write them on the web. We will collect all the questions and either at some point during the session or at the end, I will try to answer all of the questions. So don't expect an immediate answer because this is not going to come. But as soon as I have a moment where I can stop, we can go straight with answering your questions. Ready? Let's start now with the scenario. Now, the scenario is that we are at Contoso. We have a data warehouse that contains all the information about sales, and we want to do budgeting for the next year. The budget information, the data that we have available is, of course, budget data. Therefore, it comes at a very high level. We do not have budget day by day. We do not have budget product by product. The information, the only information we have is synthesized in this page. We can also take a brief look at the data. The data we have contains the country, the brand, the scenario. We have low, medium, and high as three different scenarios, and the budget, which is the total budget for that year, that country, and that brand. Now, what I did, I basically cheated. I took the sales of the previous year multiplied by a random number, and this is what came out as a result. And besides, I think this is what budget people do all the time. But we are not interested in how good these numbers are. The numbers are represented here. And from the modeling point of view, I have a table in my Power BI file that contains the budget information. Let's take a look at the data model. The data model is rather simple. We have sales, customers, product, we have a day dimension, and this part The part that you see here is basically our data warehouse, the data about consolidated information. To that, we added the budget table. Now, what is the problem of the budget table? The problem of the budget table is that we have a brand, we have a country, we have scenarios, but basically brand and country are the two main columns that we would like to use to do our slicing. And we do have the brand in the product table. It's here. We have the brand in the product table, and we have the country in the customer table. But in neither the tables, neither brand nor country is a key for a table. So it is not easy to build a relationship, or at least we will be able to build a relationship, but there are a lot of details that we need to understand as soon as we create the relationship. And in a similar way, data. We cannot create a relationship between data and budget because the budget table does not contain anything about data. It's only a yearly budget containing the grand total of sales in the year. What are the consequences of this? The consequences is that if I try to build a report that mixes sales, actually I'm not interested in the sales amount, only sales in the previous year. So let me get rid of sales amount. We have here I'm slicing by country. I have sales in 2009, and this is a correct amount, which is sliced by country region. Country region is the column country region, which is coming from the customer table. But if you look at budget, it shows the same number all the time. It's always 44 millions. Why that? Because there are no relationships between the customer, where I do have the country region column, and the budget table. So a filter on customer is not effective against the budget. And the same happens for the product. If I remove the country region and I put the product brand, same is going to happen. The brand is slicing sales, but it is not slicing the budget. If I remove the product brand and I use the brand from the budget table, the opposite is going to happen. Now, the brand from the budget table is actively filtering some of budget, so the numbers are correct, but it is not filtering sales. So I need to choose which column to use in order to analyze in the same report actuals, the sales in the previous year and the budget for the next year. The first problem that I need to solve is that of building a report that slices by columns, by the same set of columns, both the budget and the sales. Besides, we have another problem that we would like to solve, and it is that I can slice by brand, but I would also like to slice by month. So I would like to take the month, drop it in the report. And again, you see we have sales in January, February, March, but the budget is always the same. And this is kind of even trickier to solve because if I look at my data model, in my data model, I have no information about the time. I only have the brand, I have the country region, but there's no information at all about time. So we need to solve all the scenario, all these details. Basically, what we want to do is build a set of relationship between customer, date, product, and the budget table in order to obtain accurate and reasonable numbers. Let's start by solving the problem with date. We will see different techniques to solve the same problem. And we will see different techniques basically because for educational purposes, it makes a lot of sense to see different options that you have available. Let's start by solving the problem with date. I want to be able to build this report that shows month by month the amount of budget that I expect to sell in that month. And the problem I have to face is the fact that in my model, I have no information about time. I have country, region, brand, scenario, but no information at all about the time. So a relationship simply cannot be created right now. But what I can do is change the structure of the table. Instead of having one row for each country, region, brand, and scenario, I can multiply by 12 the number of rows. And by doing that, I will be able to add a column that indicates the month in which I expect to provide that amount of sales. So I will start writing code in order to multiply by 12 the number of rows. But if I multiply by 12 the number of rows, I need to allocate the sales amount because let's look at the budget data this way. If I know that a datum in China in the low scenario has to sell $171,000 of goods, how much will it sell in January? Then how much in February? How much in March? And so on. I need to allocate the value month by month. There are many techniques that you can use to allocate the value. The simplest one would be divide by 12. If you expect to sell $12 million in a year, you are likely to sell $1 million every month. Now, despite being simple, this technique that is not the perfect one. And the reason is if we just divide by 12 the sales amount, we are losing information about the distribution of sales over time and over countries and over region. I prepared a report that explains this a bit better, which is the sales distribution. Now, I totally know that numbers are hard to see, but we are not interested in the numbers. Maybe we can zoom in a bit just to have a better picture of the values. As I said, I'm not interested in individual numbers. What is important to note is that if we build a report like this that is showing the sales month by month, country by country, and brand by brand, you see that there are patterns. In January, in China, only 2 brands sell something. In February, nobody buys anything. In March, we have again a similar scenario than in January. And in April, for whatever reason, they start buying as if there was no tomorrow. And then in May, you have some sales again. So this is fake data, of course, but that's not the point. The thing is, there is a pattern in how goods are sold that we analyzed in the previous year. And that is in China. Germany is different. Germany has a different set of patterns. And USA, again, is different. In USA, sales are always high. So if we just divide by 12, we would take the amount of a datum in China in January and take 1/12 of the total of the year, and that would be wrong. Instead, what I would like to do is create an allocation factor, an allocation of values that takes into account the information about the previous year. Let me, okay, only do that. So how can I do that? Well, I would need to take this report and transform it into a query, a DAX query, that provides the same values, the same numbers that I see right now on the screen, but in a calculated table. So that once I have a calculated table, I will be able to take the total over the year and divide it by the value for the month, compute the allocation factor that I will multiply by the budget. But the first step is computing, recreating this table with a DAX query. I know it looks quite intimidating, but it is not actually. It's just a matter of writing the code the right way. So I already prepared DAX Studio, and we can just start writing the code. Let me just reduce this part because we will need a lot of space. So it's a DAX query that starts with evaluate. And then let's go back. We need to group by country region, brand, and date, because we have a country region from the customer table, brand coming from the product table, and the month, which is coming from the date table. So we go back and we start with summarize, because we want to do a grouping by. We summarize sales by, we say, the customer country region, product brand, and we also need to have the date. We could take the month name, but we can use the month number. Let me run this first query, zoom in the result, and you see we start having some results. We have country region, we have the brand, the month number. United States, Germany, and China, month number is always 111, and then we go to 2, and so on. we need, let's go back to the report. We have now the axis of the query. We need the values, which is the sales amount. So we have summarize. We need to create a new column. So we use add columns around summarize. And we want a new column that we call sales amount. That is just the sales amount. Format the code, run the query, and now we have country, region, brand, month number, and the sales amount. Let's start looking at the numbers. United States Contoso 1.4 million. We can go here, look at United States Contoso. United States Contoso in January, it's much lower than that. We did something wrong. So we need to understand what happened. What we are presenting here is the total sales amount for the year. We need to reduce the calculation to only 2009 because we want the data distribution in the previous year. So we add the calculate table around everything, where we say that the date calendar year equal 2009. Format the code again, and reduce the bit. So we run it, and now we have 395, which is the number we wanted. So this report right now produces the same values of the data that we have in the matrix, but it's just the first step. The second step is to gather the total. Remember, we want to compute the percentage of sales for every country, brand, and month against the total of all the months for that country and that brand. So we now have the sales amount. We also want to have the yearly sales, the sales at the end of the year. So we need a new column, and we do that here. We want the yearly sales. And how can I compute the yearly sales? I need to take the sales amount, keep the same filter for the brand and for the country, and get rid of the filter on time. So I will have the sales over the entire year. That's why I need to use calculate sales amount, and to remove the filter from the year, I use remove filter from date. For whatever reason, my mouse disappears. Calendar year. Okay. That should return the yearly sales. Let's take a look at that. It's 1.424, the sales in the full year for United States Contoso. As we always do, let's check the numbers. We need to zoom in. Adventure Works, no, Contoso, the full year goes to, no, that's a different value. So I made some mistake. Indeed, I don't need to remove the date, the filter from calendar year, but from month number. Okay, now it's 7268. Let's look at that. And it is 7268. So good. So now we have the sales amount, we have the yearly sales. If you remember that, we are totally not interested in the yearly sales. We are interested in the ratio between the sales amount and the yearly sales. We could compute it as another number, or we can just say, well, since I'm not interested in the sales amount, I can compute it as a percentage, and I divide the sales amount by the yearly sales. We need to close divide, format the code, and now this percentage computes the sales against the sales in the year. And if I run it, that tells me that United States Contoso in January should sell 5.44% of the total sales of the year. That is the first number that I wanted to retrieve. But it's not yet the last step, because this is the percentage. What I want is to allocate the budget, which is at the yearly level, using this percentage. Now, let's go again to the report and look at the budget data. I want to take United States, contoso this number, or this number, or this number, one of the three numbers, depending on the scenario, and multiply by 5.44%. If I want to retrieve one value from the budget table, I need to provide three different values, which are the country region, the brand, and the scenario. Given these three values, you can think about them as coordinates to find the value of the budget. Because once I know United States, contoso, medium, I know that 5.3 million is the yearly sales. There is a function in DAX that helps with that. It is lookup value. Lookup value is able to retrieve a value from a table using equality conditions. So it will search for a row in a table where some columns are equal to values that I provide. So it's just a matter of using it and finding the correct set of columns. We can create a new column. Let's call it budget. Let's call it budget value. And we use lookup value. The number we want to retrieve is the budget. This is the value. And the column we need to check are the budget country region that need to be equal to the customer country region. I can use customer country region here because customer country region is in the row context that add columns generates by iterating over summarize. So I can access both customer country region and the product brand. So I have the customer country region and I want the budget brand to be equal to the product brand. The product brand. And I also need to provide the budget scenario. For now, let me just write low. So we check medium. That's the value we used earlier. Because I just want to check that syntax-wise, I did everything correctly. If I run the query, you see that budget values shows 5306, which happened to be 5306, the value of contoso medium. So the number we are computing looks the correct one. The problem is I don't want to have medium there. I basically want to multiply the number of rows because I need to have a scenario in order to retrieve a value. But I don't want to have only the value for medium or the value for high. I want to increase the number of rows and have one row for each value. To do that, I need to increase the number of rows which are returned by this summarize. And I can do that if I cross-join the entire summarize with the values of budget scenario. Let's first run the query in this way. Now I have the cross-join of the same table that you see right now on the screen times the values of the scenario. And if I run it, you see that all the numbers are still the same, but now I have scenario as one of the column. And I have low, and at some point, somewhere, I have also medium and other values. Now I can take this budget scenario, which now belongs to the row context that add columns generates because it's part of the result of the cross-join, and I can use it here instead of medium. I know it's kind of weird to see budget scenario equals budget scenario, but you need to remember that the first column is the reference in the lookup table, so where you're searching into, and the second column is the value you're searching for. So the meaning and the usage of these two columns is very different. If I run the query now, you see that United States contoso the scenario low shows 4510. It's no longer the number we had earlier. And if we look at United States contoso low, it shows 4510. So the numbers we are creating are correct so far. Basically, this is nearly the table I want because, again, I'm not interested neither in the percentage nor in the budget value because that's still a yearly value. But if I multiply one by the other, I obtain the budget allocated in the given month. And that's exactly what I'm going to do. We get rid of this column, we multiply y by another, and this is no longer the percentage, it's the allocated budget. Now, this query is telling me that in United States, Contoso in January, we should sell $245,000 of goods in order to satisfy the budget requirements. We did it step by step, and we know this number is kind of reasonable. We have a month number, but if you remember where we started from, we are doing this giant work to build a table, to add it to the model, to build a relationship with data. We are missing a date. So let's add a date as another column. We can always go at the end of the month, which is, we just max, well, let's use e-date, no, end of month of date. No, it's calculate max of date. It's actually easier than that. That always happens when you do live demos. It's a date that contains 2010, the month number, and then 1. We also go at the first day of the month. So United States Contoso, the 1st of January, we allocate the entire budget. Now, I can take the entire code, go back to my Power BI model, and create a new table that we call allocated budget. The code is the same. I just need to hit enter, and that generates a table that contains the country region, the brand, the month number, the scenario, and all the information the right way. We can zoom in a bit just to see the different values. Remember, we started everything because we wanted to build a relationship. So it's time to do that. Now I have my budget. I can put it aside, take my allocated budget table, and build a relationship between date and date. Unfortunately, the result is not really cool. I have a circular dependency. It says a circular dependency was detected, and then a longer description. Why did it detect a circular dependency? The problem is allocated budget depends on data because it uses columns coming from data. And if I create the relationship, then the presence of the blank row in date might depend on the value contained in the allocated budget. If I want to get rid of the problem, I need to make sure that the code that generates the calculated table does not contain anywhere a reference to functions that use the blank row. If you're not familiar with the blank row, there are good articles that explain it at SQL BI website. Just search for blank row SQL BI, and that will guide you to articles that explain that in greater detail. What should we do in order to make sure that this code works fine? Apart from the fact that right now, live, a bug in Power BI is crashing everything, so we will need to wait a few seconds for Power BI to crash, and then I will need to restart. Luckily, I have the code in DAX Studio. That just happened, so let me open Power BI, and we start again. It's not that bad because we were, even if it doesn't look like, we were nearly the beginning of the demo. So we go back here, table tools, create a new table. I still have the code, and we call it allocated budget. Okay, let me see if everything is still fine. Yep. Okay. What next? So I was saying we need to get rid of references from the blank row. Where are we using the blank row here? Here we have values. Values is bad. Values uses the blank row. So instead of values, we can use all no blank row. We do not have other references. We have remove filters that does not use the blank row. And that looks like it. If I hit enter now, go back to the data view, and I need to bring back allocated budget here. Sorry for the crash, but so happy it happened. So Microsoft is gonna fix the bug. If I try to build the relationship again, it still doesn't work. Now, there is still one place in my table where I'm using the blank row. And it's easier if we see that in DAX Studio. So let's go back in DAX Studio. I need to also reconnect DAX Studio because Power BI crashed. Okay. Here you see that everything is inside a calculate table that applies a filter to date calendar year 2009. It looks like we are not referencing any blank row here, but actually we are doing. You need to remember that this condition is actually expanded into filter all date calendar year where, let me try again, where, okay, calendar year equals 2009. And if you expand the code, now you see the problem. The problem is this all. Instead of all, we need to use all no blank row. Now I can take the code, go back to Power BI, rewrite it. There was a typo here. And then the parentheses created by Power BI. Okay, if I did everything correctly, now I can build a relationship between date and data, and now it works, no longer circular dependencies. And now that I have my relationship, I can go back to the report, get rid of country region, and instead I can put the month name, the month name, and it's not showing anything because, no, I don't want to show me that you crashed, thank you. What I'm showing here is still the sum of budget, so the sum of the budget table. I need to take the number from the allocated budget. So I need to take the allocated budget, drop it here, and you see that the allocated budget is split correctly. The numbers are different because this slicer that was filtering the scenario was working on the budget. Now we no longer want to see that budget. And we also want to use the correct scenario. Okay, now if I change the scenario, you see that the numbers here, they do change, high, low, medium, and the numbers are correct. All this is to show you the first way you can allocate the budget. Yeah, it requires some code, but you can change the granularity of the table in order to increase the number of rows and perform this kind of static allocation. With that said, we are still in trouble with the other tables because we fixed the problem of date. Let's get rid of budget. But what about customer and product? Date was somewhat easy to solve because we could go on the first day of the month, whereas with customer and with product, we are a bit more in trouble. We want to create a relationship, but we cannot allocate everything to one customer. That would be unfair. I want to build a relationship between the budget and the customer, and I can't because it's not because the country region that would work as a key is not a key in customer. But what I can create is again rely on DAX. I can build a calculated table to put here in the middle that contains the country region, so that customer will go to country region, allocated budget will go to country region too, and I will use that as a dimension. That is easier to do. So let's do that. We create a new table. We are talking about country region. So Okay, country region. And I can use all no blank row. Now we know that we will want to build a relationship, so we avoid all and values. And we take all no blank row budget country region. That generates a table containing all the possible country regions. It's not perfect because what happens if I have a country region in customer that is not present in budget or vice versa? I would be in trouble. So I want to union the two tables, and I create then all no blank row of customer country region. And finally, I union the two together. So by unioning the two tables together, now I obtain a table that contains both the country region from the customer and the country region from budget. But as you see, all the values are now duplicated. So this is not a good idea, but I can always do a distinct later. So now I have distinct around everything, and the result is way better. Now my result contains all the country region, regardless they are coming from budget or from customer, unioned and with a distinct outside it. I use a set of functions that let me create the relationship without issues. So next step will be taking the country region and build the two relationships, one here and the other one that way. Now that I have my country region, I can go back. We can get rid of the month now. We are no longer interested in time. We solved that. If I use the country region from the customer table, nothing is going to change. You see that if I use the country region from a customer, the budget is still always the same number. So this is not solving that problem. But if I use the country region, which is coming from the country region table, that country region filters both the sales and the budget. I also need to get rid of sales into sales amount. So now I'm able to slice by country region and by month. And as you might guess, the two work together. So I can add the month on the rows, expand it, and now I can slice by both country region and month at the same time. So we have seen two different techniques to solve the scenario. One is a static allocation using a giant DAX query. That was good for time, and that is a kind of calculation that you can also do in Power Query if you wish. Then we have seen another technique that requires creating a calculated table, put that in the middle, and use that as a dimension instead of the other one. There is actually another way to solve the same scenario that requires creating a weak relationship. Let's use that for the product. So we have one technique for date, one technique for the customer, and let's use a third technique for product. So we see the full spectrum of possibilities. What happens if I build a relationship between brand in budget and brand in product? Because I have brand here in product. I also have a brand here in budget. I know brand is not a key in product, but I could try to build a relationship anyway. I take the column, I drop it there, and it kind of work, meaning that it seems like it let me create the relationship, but it provides a warning. It says the relationship has cardinality many to many. This should only be used if it is expected that neither column contain unique values. And that's exactly what we know. We know that the brand column is unique neither in product nor in budget. And that the significantly different behavior of many-to-many relationship is understood. This is where things go south. What is the meaning of that? If you understand something that I'm not willing to explain you, then you can go further. Now, I don't know what you do when you see a warning error message that you don't understand. But what I do is I click OK. say, well, something is going to happen. Let's see what. And what is happening is that you have a product, allocated budget, and the relationship between the two tables has been created. And you see that it has the many side here, the many side here, and it has been created as a bidirectional cross filter. So we created a many-to-many bidirectional cross filter on the fly, which is totally cool and kind of scary. But it worked. First thing first, we do hate. I mean, I personally hate bidirectional relationships. They are too dangerous. We don't want to use them here, so we need to get rid of it. The reason Power BI created a bidirectional relationship is not by chance. The thing is, because both sides of the relationship are the many side, the engine does not know which direction you want to move the filter. The filter typically goes from the many to the one side. Now, in this specific scenario, both sides are the many side. So how is it supposed to go from, should it go from product to budget or from budget to product? Not knowing it, he decided to go for a bidirectional cross filter. But we can change it. We can say, hey, cross filter direction instead of both, you can use single where product filters budget or single where budget filter products. We know that we want product to filters budget. So we do that, and we created a weak relationship. This is a many-to-many. It's not really a many-to-many. It's a relationship at a different cardinality, but it's called many-to-many by Power BI. So it's a many-to-many weak relationship between product and allocated budget where product filters budget. Let's see if it works. We can go here, get rid of the month, for example, and we can go in the product table, take the brand, add it to the report, expand it, and it's working, which is totally cool. You see that the filter from the country region in the product is being moved to the allocated budget table. So we have seen three different techniques that we can use to move the filter. One, using static allocation. One, creating a dimension in the middle, and one, using weak many-to-many relationship between the two tables. Which one is better? You know, the answer is always the same. It depends. If you are working with, if you are building a quick proof of concept, then the easiest one is the weak relationship. That is fast, simple to create, creates no issues. Performance-wise, it's not the fastest. The best solution performance-wise is to create the dimension in the middle, because that dimension in the middle is materialized as two different relationships, and depending on the size of the country region table, you might have good or bad performance. If the size of the bridge table in the middle start to grow, then creating this table is way better than using a weak many-to-many relationship. But if we are speaking about budget, well, budget data is typically not that large. Therefore, you can use safely the weak many-to-many relationship. The static allocation is good, it's very fast, but it has the drawback of being static and requiring you to do ETL steps. So whatever you can solve with DAX, if the volume permits, it's typically better to do that in DAX. With that said, we are not yet done. We still have some work to do, because this report works and we have been able to slice by country region, by brand. We have sales and we have the budget. What happens if my users go further than that and they say, well, that is cool. Now I can use any column from the product. Can I use the category? And the answer is yes, Power BI lets you use the category, but as you see, it does not produce the correct number. The number produced for audio Contoso, for China Contoso audio, the sales are 50,000, but at the budget level, it repeats the value at the granularity above it. The reason is the relationship is moved between the two tables at a given grain, and the granularity of the relationship is the brand. So if you go below the brand at a higher level of detail, you will not see any change. The number will be the same, repeated again and again, and that is not very nice. Now, you could say that's fine, but I mean, everybody would understand that the same number repeated again and again is wrong. That is kind of correct, but what happens if we remove the brand and the country region? Now the numbers are all different, and you know what? They are all wrong. So producing number that is wrong is always a bad idea. What we need to do is check that we can compute the number, and if we can compute it, we show it. If we know we cannot compute the number because the filter has gone too far, then we blank out the measure. Remember that a wrong number is not an option. Producing a wrong number is bad, and it's your fault as a developer producing a wrong number if people start to work on that wrong number. The question is, how can I discover that I went too far? Let me go back to the previous report where I have country region, the brand before the category. Okay, country region, brand, and then the categories. I want to hide these numbers. There are several ways we can hide these numbers. The easiest one is to check which column has been filtered. It's very easy, but it's utterly boring, and we love DAX. We like to play with DAX. So we want to build a solution that is completely data-driven and does not require us to check exactly which column has been filtered from which table. This requires us to think about the problem at a different level. To understand the next step, so what we are doing, I need to create a couple of columns. So let me create a first column, a first measure that just counts the number of products. I know, okay. That computes the number of products by just doing count rows of product. Why is this column useful at all? Well, the reason is I wanted to see these numbers and the reason on top of them. Look what happens at the number. At China A datum, let's forget about China. We are not interested in countries so far. Let's focus on Contoso. Contoso contains 710 products. And the budget has been created thinking about 710 products. So the budget is valid if we see all the products of Contoso. But if we slice further, so if we go below the supported granularity and we start to slice audio, then we no longer see 710 products. We see only 45 products. And at that point, if we see fewer products than the products which are in the entire set of the products of the brand, then we know that we have gone too far in slicing and dicing. So we are seeing a restricted number of products, and we should blank out the number. So what we need is another measure that computes 710 here at the different categories, so that I will be able to compare this value with the value that I put here. And if they are equal, I compute the number. If they are not, then I blank it out. The measure that computes the number of products, I call it number of products at budget grain. And how can I compute that? Well, I need to get rid of any filter from my table, from my product table, except from the brand, because brand is the column that defines the granularity at which the relationship is transferred between the two tables. So I need to use calculate number of products. I remove the filters from the product table. And I need to restore the value of the product brand. These remove filters get rid of any filter from the product table. These values restores the filter only on the brand. If I did it correctly and I put products at budget grain here, you see that it shows 710 all the rows, because it's removing the filter from the entire table and restoring only Contoso. So it computes 710. And at that point, I can go to my allocated budget. Right now, allocated budget, I think it's just the column. Instead of that, we create a measure. Let's call it how it should be called at the end, forecast, that checks if the number of products at budget grain is equal to the number of products, then we compute the sum of the budget. Otherwise we blank it out. We do not produce any result. Let's format it as a decimal number with commas. Where is it? Here. Okay. I made some mistake in forecast. It's not the sum of budget, it's the sum of allocated budget. Otherwise, that number would make no sense. Now you see that I show a value if I can. So when I'm at the correct grain, I show a value. And when I'm below the grain, I blank it out. That's the expected desired behavior. If I can compute a number, I show it. If I can't, I just don't show anything. Once I remove a number of product and number of product budget grain from the report, we can get rid of this, and also the allocated budget column. Where are you? Here. Now this is much better. And you see that it works also when there is only one category. A datum only sells cameras and camcorders. Therefore, this number 177 is indeed correct. It's not wrong because I'm still seeing all the products at the correct grain. Now, I did this for the product. As you might expect, I need to do the very same for the customer. So I need to create a column at the customer level. A new measure, which is number of customers, which is count rows of customer. So I put it here. And I need not to slice by brand and category. Instead, I want to slice by country region. Okay. And then another measure, which is the number of customers at budget grain, which is calculate number of customers, where I remove the filters from customer and I restore the filter from country region. Country region, yep. Now, actually, it's more elegant if we use values of customer country region. Okay. Now I can put customer as country region. It shows the same value, but if I expand it further, so I put the education, for example, the two numbers should start to produce different numbers. You see 11 here and 1791 here, which is way more correct. And finally, in my code, in my allocated budget forecast, I need to add a further check that says if it is true that at the same time products at budget grain is equal to product and customer at budget grain is equal to customer, then I show the number that I want to show. So far, by using this code, I basically protected my report. Now it works at this level. If I add the education, it will stop working. I want the education on the rows and I want to expand it. You see that the forecast is not visible if I go below at the education level. And if I add the product brand, it's going to work. So country region, brand, it is working. If I add the category, it stops working as expected. So that it stopped working. It stopped showing a value because it would not make sense to show a value there. The question is, can I do anything better than that? And the answer is yes. Look at these numbers here. I'm not showing anything as the forecast for audio contoso, but I could compute that number. I could take this number, 50,000, divided by 1 million, and that gives me the percentage of audio contoso in 2009. And I can use this number to multiply by the budget, which I have at a lower level of detail, but I can allocate it dynamically at any level. It's just a matter of doing a multiplication. And the technique to use is the same technique that we used to compute the counts, but applied to the sales amount. Let's do that, because once we reach this point, it's just the final step to obtain the correct result. So what we need to do is, not in customer, but in the budget, we create one measure that is sales 2009 at budget grain, that uses the same technique. It computes sales in 2009, remove filter from customer, not from country region, restore the value of customer, country region, remove the filter from product, the entire product table, and restore the value on product brand. This calculation returns the sales at the budget granularity in 2009. As we always do, we check it. We want a decimal number. It shows 1 million here and 1 million here, all the rows. Now I take this number, divide by that number, multiply by the forecast, and that's it. So I can go in my measure forecast, and I can take, I can multiply the sum by sales in 2009 divided by sales in 2009 at budget grain. The result of this division is now multiplied by the entire sum. And I can get rid of the if statement. We no longer need it. And we obtain a number which looks wrong. So let's do that one step at a time. Let's create, we have sales in 2009. Let's create first the percentage. So PCT, where divide the sales in 2009 by sales in 2009 at budget grain. Format it as a percentage, put it here. The number is correct. And now in my forecast, I multiply this by the percentage. Actually, it looks like it's correct. Oh, I'm missing the dots. That's the problem. I just go crazy because of the format string. The numbers seem completely different. They are not indeed. They are correct, but I was missing the last two decimal places. Okay, so now I'm able to do the allocation of the forecast dynamically. I don't even need to create the relationship, because by using this technique of computing values at different granularities, I can compute this percentage and produce a correct number. Now, you need to pay attention to one important detail, and it is that this number, the number I computed right now, is wrong. And it's important to point that out, because let's see how the percentage has been computed. This is the percentage of sales in 2009 divided by sales in 2009 at budget grain. But this number, despite being correct, given one brand and one country, it will not be correct if we aggregate over them. We can understand that easier from here. Look at what happens for A datum January China. A datum January China should be 0. We should not allocate anything here. But if we go at the lower level of grain, so at in less detail, we can take the value of 29,029,000 of United States divided by the sum of all the countries, and that would produce a percentage here in January for China. So the entire allocation works if you do that at the correct level of grain. If you go at a different level, it will not work. That's why if we want to make the code correct in the calculation of our forecast, we need to always go at the correct granularity and aggregate later. So the correct version should be written like keep filters all product brand, all cross join, all product brand, all customer country region, and then we need a calculate around everything. Okay, this is nearly the same calculation, but now it is always happening at the lowest level, at the highest detail, so at the highest granularity, and aggregating values later. The numbers would be slightly different, well, not different in this case, but if I slice by different attributes, it would be slightly different, and this formula is way more correct. There are good news and bad news, as it always happens near the end of any session. The good news is that we learn a lot of interesting technique to do the different allocation of the budget at different levels. The bad news is that what I'm going to say next is like we wasted an hour. That's not correct. We did not waste an hour, but if you think about the last technique that we learned, this last technique let me do a dynamic slicing at any level. I can slice by category. I can get rid of the category, and I can slice by color. It will still work. It does not matter how deep I go or where I go, I will be able to dynamically reallocate the budget. So I basically do not need any of these. I do not need this country region table. I do not need the date. I do not even have the allocated budget because I could have done the dynamic allocations also over time. So the gigantic query that we wrote using DAX Studio here, it was very nice. It was very useful in order to understand the topic, but it's a waste of time. You can, once you learn how to dynamically allocate the budget, you can do everything with just dynamic allocation. So the entire session so far was basically to explain you this formula that you will find in the PBIX file that you can download, where I compute the forecast and look at the model, the final model, which is, in my opinion, the best. It contains only, here we go, weak relationship. This is a many-to-many relationship between customer and budget, a many-to-many relationship between date and budget based on a column year that always contains 2010, and the product is linked to the budget. So the model does not contain the allocated budget. It only contains the original tables that were there at the beginning of the session. The code is completely dynamically allocated, and I want to show you quickly the formula. So we have the forecast. I'm just looking if there are any questions. Doesn't look like. This formula, as I said, you will find it once you download the demo file. It looks extremely complex, but we spent an hour to explain you the steps that brought us to this code. We have some X over keep filter, the cross join of brand and country region, which is where we do the calculation. Then we store in a variable the current brand at the current country just to have it handy. We compute the sales in the previous year. This is the equivalent of sales in 2009. In the previous version of the code, we fix the year and we say it's 2009. This version is a bit more flexible and says, well, I will go in the previous year. I compute the sales in the previous year. The sales in the previous year are the budget grain. What does it do? It computes the sales amount, getting rid of the filter on the product and fixing the brand, getting rid of the filter on the customer and fixing the country, and taking the entire previous year. Then it computes the percentage, dividing the sales in the same period last year by the sales at the budget grain. This is just useful to say if you didn't select any scenario, I take medium as the default and then does the multiplication. So despite looking extremely complex, actually it is complex, but this is the very same pattern we saw during the session. And it worked just fine. You see, I have the sales amount. Now in this model, I went a step further. And I'm also showing sales up to the 15th of August. So we have 2010 already started. We have the sales amount, the forecast computed with the formula we have seen so far. You see that sales amount stops in August. Forecast reaches August, but then goes further. You can easily create other calculation based on the same core calculation. The remaining forecast. What is the remaining forecast? You go for the last date for which you have sales, and then you compute the forecast for only the dates that happen to be after that date. You see that the remaining forecast shows a blank up to August and then starts showing numbers. It shows some value in August because actually my sales end on the 15th of August. So August is in the middle between actuals and sales. Based on the same calculation, I also computed sales and forecast. Sales and forecast combines sales and forecast together. It just sums the sales amount and the remaining forecast together, because when one is blank, the other is not. As a result, you can simply sum one with the other and obtain the result. And finally, the adjusted sales and forecast. This is where I'm really creating numbers out of nowhere. But since you see that the forecast is quite always lower than the sales amount, that means we made a mistake. We forecasted the value that is too small. And you can compute the percentage of your error, 39.86%, and use that percentage to compute, to correct, not the past, because the past is already actuals, but the future. And you say, well, in the future, I have some figures, I multiply them by the percentage in order to increase them and have a better prediction of what might be the result. One of the beautiful details about these formulas is that they work also when you change the filter context. I have created the same set of calculation with a YTD, the YTD of the sales amount, the YTD of the forecast, the YTD of sales and forecast together, or the adjusted sales and forecast. And these calculations are as simple as applying a YTD. The YTD of adjusted sales and forecast is nothing but the calculate adjusted sales and forecast with a dates YTD that changes the filter context, and the same for all the other YTD. Once you have all the calculations in place, you can build this chart. This chart is pretty nice because it shows in the black line is the forecast, only the forecast. The year to date, this is a year to date, and that is why it shows a line. The sales amount is this line, which has the nasty behavior of sales amount that you see, it reaches August and then it becomes a straight line. And I hate to see charts like this. I mean, either you stop it there or you do something. And that's something that you can do is extend from after the 15th of August, extend the chart with the forecast. That's exactly what year-to-date sales and forecast does. Whereas the blue line is the year-to-date sales and forecast adjusted with the correction factor. Now, all together, you see that these techniques are simple. If you look at the code of all the measures in these PBIX files, they are all simple. There's only one measure that required a lot more time to be explained, which is the forecast. And that's the reason I prefer to spend most of the time in showing how to build the code from the beginning. I'm pretty sure it's a lot of details to digest in only one step, but the good thing about videos is that you can see them again and again, and you can also download the PBIX file, study it, learn it, and use it. I do not pretend that this to be the perfect budget. It is not. I mean, budgeting people, they do a lot of reasoning on top of numbers. This, in my opinion, is a good example of how you can use Power BI and DAX to obtain numbers that can help you in the creation of complex scenarios. I have just 5 minutes left, which I think if we have any question, we can answer a question. I was looking at the question panel, didn't see any, so I didn't stop so far, but maybe somebody has anything to ask. Oh.
Hey, Alberto. I think we have just one question at the moment from James B, who is asking where he can get the PBIX file from.
Okay, I uploaded the PBIX file on the past website. I was very, very late. I think I did it yesterday, so it might be that it's not already online. But when you will download the session material, you will have access to the slides. And as you have seen, the slides do not have a lot of content in them. Whereas the PBIX file is where the entire logic is there. You have both the starting point PBIX file that you can use to practice and experiment, and also the final PBIX file where you have the full code containing the final solution.
Perfect, thanks.
Okay.
And I can't see any other questions. I'm a finance person, and from a finance point of view, would anything change if you were doing your budget via by department or a job type as opposed to brand, or it would all?
Yeah, I mean, what we did was using the brand as an example, but it could be anything else. The idea is you have columns that define the granularity of your budget, and these columns need to be related to the model if you want to show actuals and budget at the same time in the same report. The way you call those columns a brand, country, or department, or whatever, that really does not matter at all. And again, to me, it's important to understand what you can do. Then every single company has its own way of doing budgeting. I still have to find 2 different companies that do budgeting and forecasting the same way. Power BI is kind of useful to build numbers that then you reason on top of them. I don't pretend that they are a complete budgeting solution, but they are a good help in obtaining better figures.
Thanks.
Okay, if we do not have any other question, thanks a lot everybody for attending. I hope you enjoyed it. Remember, go to the evaluation page, provide an evaluation, give us feedback, whatever. Whether you find it awesome, whether anything didn't work, we want to understand to make it better the next time. Thank you a lot.